Okay, guys, welcome back. It's Wednesday? No, it's Monday. Okay. Hope you had a nice weekend. Um, okay, so today we're going to switch gears a little bit, and I think we can all take a collective breath because, uh, in my opinion, things are going to get quite a bit easier in terms of we're done all the major Python concepts and programming concepts. Um, everything you now know everything you need in order to understand pretty much all of Python. Um, Now all that's left is practicing and using convenient tools that I'm going to show you. Okay. Before I get started on this, are there any questions about the assignment or anything in general? Is it going okay? We're almost done. Yeah, very good. Okay. So, today I'm going to give you a little tour of what's called the standard library, okay? So the standard library is just a bunch of modules like what we talked about last week, or on Monday. Oh, wait, no, today's Monday, sorry, Jesus. Okay, last week we talked about modules, and you can make your own modules. It's just a piece of Python code that has some file, and somebody else can drag it into their code and start using it, okay? So there's three types of modules. Modules you can make yourself, third-party modules, so modules that other people have made and they've posted online somewhere, like we saw with how you can install things with pip and conda. So we've already used a few of these, like matplotlib and numpy. These are really popular ones. And there's another kind called standard library modules, okay? So the standard library is really just a bunch of modules that come with Python kind of in the box, okay? These can do a lot of useful things that are kind of very standard. So it just comes with Python. Most people are going to need to use some of this at some point while they're coding. And it's good to know about them. They're very well maintained, so they're high quality, usually very efficient. And it's good to just have a little idea of what kind of things you can do with this. Obviously, it's a pretty big standard library, which is kind of one of the reasons Python's really popular. There's a lot of things you can do right off the bat. And so I'm just going to give a very quick kind of run through of things you can do, okay? Obviously, there's a lot more, so I have these links with complete documentation on everything I'm going to mention. And I would just take note, make sure you use it once or twice, and it'll, if we ask you to do something, you'll know that there's a module that can do that for you really quickly, okay? So I'm going to kind of go through them in terms of what kind of task they help you with. The first one is, before that, I just don't want this to be confused with built-in objects. Okay, so there's the standard library, which is just modules, and then there's the built-in objects, which is like the print function, the zip function, the enumerate function. These are all things that are built in that come with the interpreter right away. And you don't have to import them. So things from the standard library, you still have to import them. You just don't have to install them. The code is already there when you download Python. Okay. So the first thing we're going to look at are three modules that help you deal with kind of everyday operating system tasks, okay? And these are called sys, os, and shutil, all right? So they each specialize in doing a different thing. For example, sys is really useful for handling how the Python interpreter actually works, okay? So you just import sys, and you can get some information from it. So I think I showed this last time, but you can get, for example, I'm putting a lot of this stuff in f-string so that you can see the output formatted nicely, but this is really the code that's running, okay? So the system module has an attribute called sys.executable, and that tells us in which folder of our computer the Python interpreter is located, okay? So in my case, it's in the users folder inside my Carlos folder, Anaconda Python 3.6 bin Python, okay? So here, this is really just a file of code that runs whenever you're trying to run some Python code, okay? So you know where that is. It's just a file on your computer. We saw this one last time, sys.path, right? That tells the interpreter where to look when you try to import something. And it's just a list of folders in your computer. And it goes through this in order. So when you say import something, it'll first look in the first item of this list, which is just an empty string, which tells it look in the current directory that you're in. if it doesn't find it there, it moves on until it exhausts this list, and if it does, then it'll give you an error. If it doesn't, then it means you can use that module. Another useful one is sys.exit. So this is a function call or a method that basically kills the interpreter. Okay, so if Python ever executes this, your code's going to stop. All right. So break breaks you out of a loop. Sys.exit breaks you out of your Python code entirely. So if I were to run this, I would get this exception called system exit. Okay. So it's useful if, I don't know, for example, you're writing some code and you think that it might never terminate or something. You put a sys.exit, make sure it stops at that point. Okay. Another useful thing that it does is, maybe this is a little bit of a new concept, but when we were talking about getting input from the user, meaning the program wants some information that the user has to type in, like give me 2 numbers to add, you type them in, right? We've been doing this using the input function, right? So Python's running some code, it sees an input call and it stops and it says, prints to the screen, give me some numbers. And then once the user puts them in and hits enter, Python keeps running, okay? So this is nice because if you're working with people that are going to use your program, maybe you want them to sort of be interacting with your program and giving it information as it goes. But sometimes you want your program to be a little bit more automated. So you don't want, you want to kind of just like launch your thing and go somewhere else and let it run and you come back and it's done. You don't have to be in there like giving it directions, okay? So, you know, before when we had input, we were doing something like this, right? If I wanted to divide 2 numbers that I want the user to give me, I would say, well, input, give me the first number. Python waits until I enter something here and stores it and gives it the A name, and then same thing for B. And then we can move on to this part of the code, okay? Yeah. Now, there's a sometimes more convenient way of doing that, and that's called through command line arguments, all right? So the thing that takes care of this is the sys module, okay? And it looks very similar. So the only thing that changes is the way that you're actually giving information to the program. You give it to it actually before it runs. So, oops, sorry, I had a typo in there. So I would have to go outside of the notebook because there's no command line in the notebook. So for example, let's say you know, I'm running from my command line here. Okay, I'm in here. These are the files that I'm looking at, and I write some. Let's go to my temporary folder. Okay, let's say I write a little Python function that, you know, adds 2 numbers. All right, from the command line. So I would do something like this. I'd import sys, and I'd say a equals sys.argv. I'll explain what this does. 2, but you can already get an idea. So I'm going to convert this to an integer, and this to an integer. Okay, and then I'm going to say print a divided by b. Okay. So the way I would actually use this, and pretty often if you're writing some code that's actually going to be used by other people, they're going to be doing it from the command line. So you want to run the Python interpreter, and you want to use the add.py Python file. And I need to give it 2 pieces of input, the 2 numbers I want to add, right? Or I think I actually divided them, but whatever. Let's say it's 3 and 4, all right? So I actually give them as values as I'm launching the Python file, okay? Okay. So I have a typo here. Okay, and let's actually add them. Okay, so there you go. So my Python file can run and terminate without me having to do anything in between, right? I give it my input from the moment that I'm launching it, okay? So it'll take this number 3 and this number 4, and it'll add them. The way that works is the sys module stores these values that I give when I'm calling from the command line in a list. So if I were to print that list, it would look something like this. The list is sys.argv, which stands for arguments, and v, I imagine, vector. So there you go. So it printed the list. So it's just a list of strings, basically, that you type in when you're using Python. The first string is the name of your program, and you can specify as many as you want. They'll go into this list, okay? And from your program, you can use this list to do whatever you want. Does that make sense? Okay. So yeah, it's just a list of strings. The difference is that you don't have to interrupt your program. It's just the user gives it the values it wants it to use, hits enter, and the program should, start to finish, it shouldn't get interrupted. Okay. Another big one is called OS. So this one is acting more directly on your operating system, and it has some useful attributes. For example, os.name. So my operating system type is os.name. So it knows that I have what's called a POSIX type of operating system, which basically is Mac and Linux and stuff like that. Windows will have a different value. So if you're writing some program that depends on what operating system is being used, you can use that attribute to figure out, whoever's using your code, what operating system they're going to have. I could also find out what directory I'm running Python from right now. That's os.getCWD, which stands for get current working directory. Okay, and basically that just gives me a path, right, of where my Python interpreter is launched from. Okay, so see, it's in my users folder, Carlos, projects, notebooks, and lecture 24. Okay. You can also change where you are right now. You can change your current directory to somewhere else using the chdir, change directory method. Okay, and all that does is it takes as input the path to somewhere else, and it'll change your current directory to there. So if I did that, now I've changed directories to my projects folder. Okay. So that would affect, for example, if you're looking at some files in your current directory, obviously they'll be different depending on what directory you're inside of, right? It's just like jumping around your Finder thing, right? Remember that by default, Python only sees what's in its current folder. So if you move to somewhere else, you're going to see different things, okay? And the way to see those things in the folder, again, is using the OS module function called listdir, okay? So it lists your directory. And these are all the files that are in my current directory, okay? If you don't give it any arguments, like I said, by default, it looks where it is currently. So that was in my projects folder. If you do give it a path, so some specific directory you want to look at, it'll look in there instead. All right, so these are the files I have in this lecture 24 folder, okay? And let's just go back, let's just change back to our original directory, which was lecture 24, because that's where we're going to be working from. So now we're back where we started, okay? Another useful one is you can create folders from Python, okay? Intuitively, again, this is os.mkdir, make directory, and you just specify the name or a path to a directory, right? So because I'm not giving it a path, it's assuming that I'm going to make this folder called temp inside my current directory, right? So I hit enter there, and if I list all my files that are in my current directory, I should see this folder temp in there. Okay. So that's the OS module. Any questions? All right, I'm just going to keep going. Yep.
So you can control the OS from Python.
Yes, exactly. Some things. Yeah, a lot of things actually.
Why?
Yeah. Yeah.
It's basically as if you were in command line.
Yeah, pretty much. There's other methods that actually let you fully imitate the command line. This one is just specifically for specific actions like changing directories and stuff, but you can have arbitrary command line arguments run from Python if you want. That's called the sub-process module. It's useful, but kind of beyond the scope of the course. All right. So this one, shutil is basically used for manipulating files, okay? Not the content of the files, because we have already done that by opening files and reading them and writing them, but actually, like you do on your Finder, like, moving into different folders or deleting them or, whatever you want. So let's just create a file here. I've opened this file text to write, and I just wrote hello to it, all right? So I should have this file in my current directory. Let's list my directory here. I should have a file called test.txt. Very nice. Okay, so let's say I want to make a copy of this file, right? All I have to do is say shutil.copy file, and the first file I give it is the thing I want to copy, and the second argument is what I want it to copy to. So I want to copy my test.txt to another file called testcopy.txt. Okay, it prints out the file name. So basically, I've just made a copy of this file. If I were to look at it, let's see where I am here. Courses, com364, slides. Oh no, what's my current directory? Notebooks. Yeah. Okay. Projects. Notebooks. 364, lecture 24. So I should have a file test.txt, which is just says hello inside. That's good. And we should have a copy of that file here, hello as well. Okay. So I mean, you can imagine this is useful, you know, if you want to do some like automatic things with your files. Like, let's say you want to get rid of all your JPEGs or something, you can do these kinds of commands to like automatically do these things. So you don't have to be like clicking and dragging like a moron. Okay. So we've made a directory, we've listed it, we've copied a file. We can also remove folders. This is, again, in shutil, you say remove tree and you give it the path to a folder, okay? And that's just going to delete it, right? And if you want to remove a specific file, for some reason it's in the OS module and you say os.remove, you give it the name of the file, I run that, and I should no longer see my test copy in here. Yeah, it's gone. Okay, so these will come in handy. Probably like maybe in the last assignment or something like that, it'll come in handy. And in general, feel free to play around with it. Another useful one is the math module. Well, not the math module. There's a few modules that do math. Okay, we're going to look at math and random. Statistics I'm leaving out because it's not very interesting, and NumPy does it better. But basically, math. If you say import math, we've already kind of worked with this a little bit, but you can get some numbers, some special math numbers, and some special math functions. For example, you know, let me run these a bunch of these function calls. So math.exp takes e to the power of some number. So this would be e to the power of 2. If I wanted to take the log of a number, I could say math.log, right, and it will compute that. Math.power. So if I wanted to take, you know, for example, 3 to the power 4, I would just say math.power. Do the sine, cosine. There's a bunch more. So you can just look at the list of all these functions. So, you know, that might come in handy. One that's very useful is the random module, and especially in this assignment, it'll come in pretty handy. So this one lets us do things with random numbers and randomness in general. Okay. The main way it does this is by generating these pseudo-random numbers. Okay. And what we mean by pseudo-random, it means that it's not a perfectly random number. There's no way to actually create a perfectly random number as far as anyone knows. So Python just kind of makes it so that it's really hard to predict what number is going to come out, but you know, it's not guaranteed to be 100% random. So you just say import random, okay? And like maybe some of you guys have found out already, you can say random function, and that's going to give you a random number between 0 and 1. Okay. If you wanted, for example, a random number between 4 and 15, you can say random.randrange, and you give it a range where you want your random numbers to fall into. Okay. Let's say, you know, these two functions give you random numbers sort of uniformly. So that means every number in the range is equally likely to happen. But sometimes you don't want that. For example, let's say we want numbers with a Gaussian with a normal distribution. Okay, so the mean is more likely and the extremes are less likely to happen. You can do this with the random.gauss method. You give it a mean and you give it a standard deviation, and it'll generate random numbers from that distribution. Okay. So I'm going to run that. See, so we create a uniform random number here between 0 and 1. I got 0.89. Random number between 4 and 15. I got 6. Random Gaussian number. Yeah. All right. If I run that again, I'll get different values, right? Every time I run it, I get something random. Okay. Just for fun, let's check that we're actually getting these distributions that Python's promising us. The way you could do that is call this function a bunch of times and see, if you're actually seeing every number sort of the number of times you expect it to happen, right? For example, if it's a uniform distribution between 0 and 1, you should see kind of every number represented just as many times as the other, usually. Gaussian distribution, it would look something like a bell shape, okay? So I'm just writing a little function with math.lib here, doing a histogram, where I'm plotting the value that I get from this random function and how many times I see that value after calling it a bunch of times, okay? So this function just takes a bunch of numbers and it's going to make a histogram for them, okay? So I'm going to test the uniform random number generator. So random.uniform kind of does the same thing as random.random. And you can give it a range. So let's say I want to know between 10 and 15, am I getting randoms uniformly random? Well, what I'll just do is I'll call this, I'll make a list of samples from this call, and I'll do it 1,000 times. I'll call this function 1,000 times, and I'll put it in this list comprehension, okay? And then I'll just plot the histogram of that. Now I'm also going to test the Gaussian random number generator. I give it some average and some standard deviation, and I call it 1,000 times. And I'll see, just count how many times I see each number. So if we run this, hopefully we'll get something nice. Okay. So this is where we call this uniform random number one. So, this is how many times we saw each number, and these are all the numbers on the range. Okay, so it looks pretty uniform. I mean, they're all kind of happening the same number of times. If I ran it more times, it would look more like a flat thing, which is what we would want. And the Gaussian looks pretty good too, right? So I gave it a mean of 0, meaning on average I should get 0 most of the time. And about 60% of them should be between -1 and 1, and the rest should be in the tails, okay? So it looks like, Python's doing this job nicely. We've generated some random numbers, okay? So yeah, I recommend for assignment 3, you use the random.random function to do your mutations thing. I'm not going to say more about that, but you have more than enough to do it now. This is also going to be useful in the assignment. You're going to have to take random things from lists. Okay, so if I give you a ball of marbles, Python can sort of sample things randomly from that ball of marbles. Okay, so let's say I have this list, right? Just random strings here. I can pick one of these at random, saying random.choice, and I give it a list to pick things from. Okay. It should pick things uniformly randomly, meaning every item in the list is equally likely to be picked out. For example, if I wanted to do a coin toss, I would have a list of heads and tails, and I would just randomly pick heads or tails, right? You can also shuffle a list, right? So if I had my list of birds here, right, it goes duck, goose, eagle, swan. If I call this random.shuffle, it's going to make a permutation of all the items in this list, so the order is going to be shuffled, and it does it in place. So you don't get a new list, it really just shuffles things in the same list. So if I run this, this random.choice gave me duck, and heads or tails gave me tails, and the shuffle put the eagle first, then swan, then goose, then duck. Okay? So these are really handy things in general. Any questions with that? There's a lot more. Obviously, look at the documentation, but these are the basics. Okay. So this is the one I kind of failed at showing last time, a few lectures ago, the collections module. I bring it back because it is useful, and it does work, and I just had to load Python 3. But basically what you do is you say import collections, and you're going to have a bunch of tools to make working with things like dictionaries and tuples a lot easier. Okay. For example, I'm going to show you two, counter and name tuple. The counter object belongs to the collections module. So I can say collections.counter, and basically I'm saying I want you to count things in this list. Okay? So I just have a list of strings here, red, 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 black, red, blue, blue. If I pass it to this counter object, it's actually going to automatically count how many times each thing of that list occurs. So I ran that, and it gives me this counter object, and it looks like a dictionary, so it automatically said there's 4, this thing red happens 4 times, this thing blue happens twice, this thing black happens once, okay? So you don't have to write a for loop and all this stuff, you can just call this counter thing and it'll count occurrences for you. And you can access it like a dictionary, you could say C, right? So your counter dictionary at index red, and there's 4 instances of red. And for example, there's this function called most common. So this would be an instance function of the instance C, where you can say 2. So give me the 2 most common items in this list, okay? So that would be red and blue. All right? It's good? Okay, now name tuples. So name tuples basically let us forget about the indices of tuples. I don't have to remember that at 1 I have my student ID and at index 2 I have my name or whatever. I can just give these informative names. The way you do that is you define a named tuple. So you go collections.named tuple. You give it a name. So this type of tuple is going to represent the student. And a list of what each position in your tuple is going to mean. So if I had a tuple like this, for example, it would say Carlos 3.1 and computer science, right, in a tuple. I can say, well, the first index means name, the second index means grade, the third one means what major you're in, okay? Then I can just create as many of these as I want by saying student and then passing in the arguments. So you're actually creating a new object here. So I just give it the name, right, 2.1, I'm in my major, and now I have a tuple, but it also has attached to it some names. Like if I say s.grade, it'll give me this, s.name, it'll give me this, instead of having to say s at 0, s at 1, right, s at 0, Carlos, right? So it's still a tuple, it acts like a tuple, but it just has this layer of labeling on top. It's going to be useful for example, if you're reading a CSV file and you know that each column means a specific thing. So let's say I had a CSV file with a bunch of students. I know the first column is the name, second column is the GPA, and the third column is the major. I can assign names to each of these columns. So I have this CSV file here, test.csv, that looks like this. And I'm just reading it in. So with open CSV, read it as students. And I'm going to say for every line in this file, so for S and students, I'm going to create this named tuple where I can easily know how to access every field. And from that, you use this function called _make, which basically takes in a list, and it assigns the tuple in order of that list. So let me make this a little more explicit here. Line equals this. So if I were to print this, right. So what happened was, I'm opening my file. For every line in this file, I'm gonna strip the line of the enter at the end, and then I'm gonna split it by comma. So I'm gonna get a list of every row split up by commas. So this list is gonna have in this first position the name, then the GPA, then the major, right? So now I have a list, and I can create a named tuple from it. Yes?
Is it the split part that makes it into a list?
Yes, it's a split part. Yeah. The strip just takes off there's an enter character after each line that you just want to get rid of. So that's what the strip does. It just cleans up the string.
But before that, the line isn't already a list.
No, it's not. If I were to do it before that, I would say, like, for example, print s, and it would look like this. See? That's just a string. Then it gets turned into a list. So once I have a list, I can pass it to this _make function that makes a named tuple out of that list. And automatically it knows that the first thing is the name and so on. Okay? So let me clean this up a little, and then we can see how it actually worked. Right, so these are all my named tuples. Right, name equals Carlos, grade 2.4, major CS, and so on for all the grades. Okay? So now if I wanted to get everyone's average, it'd be super easy. I just look at the grade the grade name instead of having to remember that it's index 1. There it is. Okay, this one you learned about in the midterm, but I'm going to go over it again. The date time. So, date time helps us handle dates instead of, it just does it really nicely for us. You just say import date time. I didn't feel like typing date time every time, so I just imported it as dt. Now I can create a new date object. Okay, we know what objects are. Basically, it's just data with specific names. So, I say dt is my module, dot date. It means I want to create a new date, and I give it some information. So I want to represent the date 2017, 11, I guess November 9. Okay, and now I can work with that. For example, I can say what year is that? I can say date.year. Okay. If I want to know how many days there are from now till Christmas, I would store Christmas as a date object. Right? I say dt.date 2017 12/25. Now Python knows which one's the month, which one's the year, which one's the date. And now I can actually do like arithmetic with the dates, right? So I could subtract two dates and I'll get the number of days between those two. So I'll say until Christmas, there's the date Christmas minus the date today. So dt.date.today is just going to be one of these, but it knows what today is, so you don't have to keep entering it. And it turns out that there are 49 days till Christmas. Okay. You can also know what weekday your date is. If you say, for example, today dt.date.today, that's going to produce a date object, and the method .weekday tells you what weekday. I probably should have done this before coming to class. It tells you 0, okay? So it just means Monday, so 0 is the first day. What weekday is Christmas going to be on? I'd love to know that. Christmas.weekday. Monday. Okay. Now we know. All right. So now I'm going to show you two that are kind of quality control modules. So just making sure that your code is efficient and it can be tested, conveniently. The first one's called time it. So basically, it tells you how long it takes for something to run. Okay. And I'm going to show a very simple example, but you can look into it for more elaborate details. But for example, I want to know how long this list comprehension is going to take to run. Okay. So I'm just going to take x times x for x in range 100. So I'm going to square every number until 100, stored in a list. Okay. You type that into a string, and this time it function, runs it and sees how long it took. Okay. So we run it. Okay, 7.79 seconds that took. All right. So it's good to know if you feel like your thing is slow, maybe put the thing you think is being slow in one of these, and it'll tell you how long it takes. Right. A pretty cool one that I learned about preparing for this is a module called doctest. Basically helps you write tests for your functions. Okay. So we already know about doc strings, right? They're just triple quoted strings that you put at the beginning of your function definition, and you can write whatever you want in them to explain how it works and everything. So it's we encourage you to do that, and then you can include these three greater than signs, which are the things that come up when I've done this. For example, Python, these three arrows, right? That means that you're going to execute a Python command, right? I don't know, 4 plus 3. That's a Python command. Okay. So this doctest module looks for these characters in your doc string, and it actually executes it and compares the output to whatever you wrote here as the expected output. Okay? So I have a typo here. So let's say I'm writing a function that squares two numbers. I know that if I square 5, I should get 25. So I just put it in here. My square, name of my function, I give it the argument 5, and I know that if it's correct, it'll give me 25, okay? So I'll just put that in there. It won't do anything. Let's say I want to take the mean of a list. So I just write my doc string, this function computes the mean of a list of numbers, and then this is what I would do to test it. So I put it in my 3 arrows, and I just call the function, okay? And I give it this argument, just a list of 4 numbers. I know that the mean is supposed to be 2.75, so I just stick it in there. And that's it. You can just run your Python normally, and this will never bother you. But if, let's say, you're done coding, you're about to submit your assignment, you want to test everything, you say doctest.testmod, and it'll actually run these. It'll look for these in your doc strings, run it, compare the outputs, and be like, this was right, this was wrong. Okay. So let's see that. All right. So I ran it, and it gives you this nice little message. For example, okay, my mean, it was failed. I was expecting 2.75, but I got 4.75. Like, okay, what the hell? I go back in my code. I see, okay, well, I'm taking total. For every I in my numbers, I'm adding to this total. For some reason, I added 2, right? That makes no sense. Let's get rid of that. And then I return the total divided by the number of numbers. That's just a simple average. So that's probably why that didn't work. So only one failed, and I tried 2, so I know my other function was fine. So let's see if I correct it, if it fixes. Yeah. So 0 of my functions failed, 2 of them were tested. Okay? Yep.
So it only tests if the is correct. Like if you want to test to see if the function actually works, not like if you get the right answer, then you don't test this or do that.
Yeah, I mean, it depends what you mean by works. Yeah, it's very limited in terms of, like, it just compares values.
Like in terms of like any value that you put in will work the way you want to, you can't test that. You can only test to see if one input will give you the right output.
Yes. Do you mean, like, I have to make sure that this makes sense? Like what I'm putting as an expected number?
Like you can only put in like y squared 5.
Yeah.
You can't put like y squared ABC.
Oh, and like, no. Yeah. It really just compares outputs. Yeah. That'd be cool if it could do that. Maybe there's something that does it, I don't know. But yeah, you just give it a test case and it runs that test case. Because it can't know, like, it doesn't know magically what this is supposed to do, right? So all it can do is like run it and compare what happens to what you gave it that it would expect, right? If you just give it like A or something, it's not going to know that this is supposed to be a number and it's supposed to behave a certain way, right? So yeah, it's not that smart. Okay, so we're almost done. So sometimes you're working on your code and you come up with I don't know, you need to do this some processing and you come up with a nice dictionary that has all your results in it, and that's really great. You want that to be stored somewhere so that maybe you can pick it up later and keep working with it. You can basically save it into a file. So any Python object, you can save it into a file. So when you close your Python interpreter, obviously all the data, all the names and objects you've created get erased, right? Unless you store them in a file on your hard drive, right? So the pickle module lets you do that. So what you can do is, let's say I just created this dictionary and it was a lot of work for some reason. I don't know what I do here. I just like attach some random number to a string in a dictionary, okay? Let's say I want to save that and go back to it later on, right? I don't want to write it manually to a file or do anything. I just really want to be able to stick this dictionary in a file and then pick it back up later. You do something called dump, okay? You dump it. So you say pickle.dump. You give it the name of your object that you want to store in a file, and then you give it a file, okay? So you say you open a file, you give the file a name, and you say I'm going to write a file, and I'm going to write it in binary mode, okay? So what it does is it takes your object, it represents it in ones and zeros, just because that's more efficient, and now it's stored in a file, okay? So now you know even if you close your Python or whatever, you'll have that, you can load it back later, all right? So I dumped it. Let's see if it actually wrote the file. It's here. So ramdic.pickle. It's really hard to see, but it's there. Okay. So if you open this file, it looks like gibberish. It's just a binary file, but Python knows how to decode it. And if you wanted to use it later on, you just load it. Okay. So you say pickle.load, and then you open it back up. So this thing that I created, I can read it now. The mode is R for read and B for binary because I'm reading a binary file. And now it's loaded. If I were to print it, I'd have my dictionary back. Okay.
But we're not changing real
As a real file?
A regular file.
How?
I don't like why a dump to convert to a dump file rather than a real file.
Well, I mean, as in like opening a new file and like writing to it line by line. Well, first of all, that's slower. Second of all, it's not trivial, for example, if I create a dictionary, like how would I write that to a file? It's not text, right? It's a specific data structure. So the pickle module, what it does is it breaks down that data structure into a binary representation, and then it can dump it to a file, right? And you don't need it to stay kind of human readable, so it can just represent it as binary, store it, and forget about it. Something more similar to that would be JSON store. I'll show that later, right? So pickle only works in Python, meaning only Python can read pickle files. Yes.
About the binary, like why exactly do they want to store it in binary?
It's just faster to read.
Okay.
Yeah. If you wanted to store it as normal text, you can do that with JSON. Okay. So JSON is the same thing. You can dump a Python object. It just stores it in a different format, JSON. It's slower because it's human readable, but you can do it. And it's kind of what you meant. I mean, this would be if you were to copy paste your string, your dictionary, right, into a text file, then that's what it would do. The other thing is, like, if this was written in a text file, you'd have to actually parse this. Like, you'd have to say the colon means that that's a key value pair, and like you would have to interpret this dictionary manually. Whereas the load function does it for you. It knows the structure and it can automatically load it into a dictionary. So JSON does it in a more human readable way, and it can actually work between any programming language if they can understand JSON. So it's the same idea, right? It's just you can dump your object into a JSON file. Notice I don't have the B here anymore because it's not a binary file. It's a regular text file. Like if I were to open my JSON file, it looks like this, okay? Yeah. If I were to open my pickle, whoops, it looks like this, okay? It's in hexadecimal. So it's less understandable, but the computer likes that more, okay? Last thing I'll show, my favorite, is multiprocessing, okay? So nowadays our computers are pretty powerful and they have many processors, okay? Meaning they can perform many tasks at the same time, okay? You can see that happens with my browser tabs. Every browser tab is sort of like a process, so some computations running independently, okay? And I can refresh this and then open this at the same time. They're kind of things running in parallel, okay? I don't have to wait for this to load for me to be able to open my new Chrome tab. So the same thing can apply to doing Python, okay? So basically this lets you use all the processors in your computer. For example, specifically when you want to do something that can be split up easily, like let's say I have a list, and for every number in this list, I want to compute the sum of every number up to that number and cube it, okay? I'll explain to you why I'm doing such a convoluted thing, but it could just be squaring every number in a list, okay? If I square the first number, I can be squaring the last number at the same time. Like, it doesn't matter what the output of one is versus the other, right? Every item in the list for this function is independent. Therefore, I can say, look, this processor is going to do the first half of the list, and this processor is going to do the second half of the list. Go run it at the same time and give me back the result, okay? So it's pretty powerful if you're running kind of expensive computations. So the way it works is you say, I'm going to use the multiprocessing module, and I import this object called pool, okay? Pool basically is a group of processors, so little chips on your computer that can do a task, okay? A single processor can do one thing at a time, always. But if you have many of them, you can do many things at one time. So usually when you're running Python, it's all on one processor. But if you want to be more efficient, let's say we write this function, okay? Cube sum x. So it takes a list, x. No, sorry. It takes a number, x, and it goes, all right, I'm going to do for every number up until that number. So let's say x is 5. I'm going to go for 0, 1, 2, 3, 4. I want to compute that number cubed. So 0 cubed, 3 cubed, 2 cubed, 3 cubed, 4 cubed, and then put that in a list, and then sum that list together, okay? It's just some random operation that takes, a lot of time, okay? So we can do this two ways. We can do this normal way, or we can do this the multiprocessing way. I'm going to time this, so I'm just going to use the time module, and I say, okay, I'm going to start my stopwatch. Time.time gives me the time right now in seconds. And I do my stopwatch, hit start, and then I create my list of inputs that I want to run on this function. So I have this list of numbers, and I want to run this function on every item in this list, okay? Obviously, they're independent of each other, right? So I could split this list up into chunks, give them to my processors, and collect the output, all right? So what I do is I do this with thing, which is basically sets up everything that Python needs to do to run this. It's the with, just saves you some code. I create a pool object with 4 processors, okay? So I'm going to use 4 of my computer's processors for this task, and that pool is going to be represented as this name P, all right? So what I can do is, okay, I'm going to get my result, and I can say P, so this P object, which is a pool of processors, has a function called map, which basically takes a function and a bunch of inputs, and it just sends that input to that function one at a time, right? So nums here is it's a list of numbers, and cube sum takes a number, right, and gives me this sum of cubes or whatever, right? So this automatically distributes the inputs to this function, all right? Not only that, but it also splits it up between the processors on my computer, okay? And then once this is done, I'm going to print how long it took. So I'm just going to say, I'm going to look at my watch, see what time it is. I'm going to subtract the start time, okay? At the same time, I'm going to do this normally. So that would just be, for example, calling this function cube sum on every item of the list nums, okay? That's what we would do normally. If I give you this list and I tell you to call this function on every item, you could put it in a list comprehension and say cube sum x for x in nums, okay? So this is doing it on 1 processor, this is doing it on 4. And if we run it, it'll take a few seconds because there are 10,000 items in this list. And the reason, it'll take up a couple seconds, that's good. There you go. So in parallel, so running it on 4 processors, it took 14 seconds. And now it's running on 1 processor serially, and it'll hopefully take longer. It's not always the case that it takes longer because the reason I took this weird long function, right? I just wanted something that takes a long time because it's not always faster to do things in parallel, okay? The Python needs to kind of set everything up and get everything ready for you to use all these processors. So there's some overhead, they call it. So things that need to happen, and then you run your computation. So if your computation is really quick, then it's going to take longer to set up than actually running it in 1 processor, right? So you need to make sure that you're doing something that actually takes a lot of time to use this. So yeah, see, the same thing took 25 seconds by using 4 processors, then, the same thing took 25 seconds in serial, then using 4 processors took 14 seconds. Okay, so this is useful to keep in mind when you're, analyzing big data sets and you need to do a bunch of processing. You have a powerful computer or something, split it up, right, and it'll really help you out. So there's a bunch of others that I didn't cover and I didn't have time. Not only that, but even the things I did cover, I didn't show you everything. A few I recommend looking into are, for example, regular expressions. So that helps you search for patterns in strings. Statistics gives you some basic statistics. os.path helps you dealing with all these file paths. CSV lets you read CSV files automatically, and there's a couple others, okay? So that's it. That's all about that, and we'll see you guys Wednesday.
You're talking about statistics and NumPy?
Yeah, you can do stats in NumPy better.
I mean, NumPy is just there and it's easier.